Okay, class, before we move on to some other shapes, let's just summarize what happened with our circles here. Turns out a circle in polar form is going to be r equals some value times the sine of theta or some value times the cosine of theta. And if we looked at what we discovered there, the radius is half of this value. Okay, so the radius here wound up being 2, and the radius here wound up being 1. And we've got a theorem here that can help us describe circles in any of these forms. So if I've just got this scenario here where r equals, if I can make this be 2a, that's like 2 times 2 for the 4 sine of theta. So we've got a radius of a, whatever's half of this coefficient of the sine, and it's going to be centered at 0a. So in this case, this would be your 0a. And the only thing that's going to change if we put a negative in front of that 2 is it's still going to have a radius of a, but now it's going to be centered at 0, negative a. So that would have brought it down here instead. It's the center. And then for the cosine form, it's going to do the same thing to the right or the left of the pole. So we take half of whatever the quantity is here. In this case, it's 1. And if it's positive, it's going to center to the right. And if it's negative like this one was, then it's going to center to the left. So you can pretty much identify which type of circle is happening and where it relates. And then the circles in these forms are going to pass through the pole. Okay, so this passes through the pole on one extreme, left or right of the radius. This passes through the pole at bottom or top extreme, because we're talking sine, which is y, versus cosine, which varies the x. Okay, now we're going to move on and look at some shapes other than the circle. Okay, class, we're going to take a look at a shape called a cardioid, and that's kind of a heart-shaped graph. And in polar coordinates, it's going to be identified if it can fit into one of these 4 items up here. So it's either going to be some constant. So let's lock an a into some value here. Okay, let's say if a was 10, then I could say r equals 10, and we'll go with the plus 10 times, we'll go with cosine of theta. Okay, and we're going to discuss how you can identify the way that graph's going to look just based on which of these bullet items it matches. So let's do one here. In this case, if we took this example 7, we've got a is equal to 1, because if I were to factor something out of this, r is equal to 1 times 1 minus 1 sine theta. Okay, and the thing that's nice about this is that sine and cosine are going to deliver different results. So the heart's going to be kind of shaped like this if it's a sine, because the sine corresponds with the y-axis. And if I were to make that r equals 1 times 1 plus sine theta, all it's going to do is put this piece with the distance here, in this case it's going to be twice r. So notice that the radius from the pole to either the bottom or the top, in this case, is going to be 2a, whatever a might be. So if we graph something with a 10, that means that our radius is going to stretch out to 20. Let me give you an example from a graph here. So what happens with this cardioid? Okay, so here I'm going to use an a of 10. Now what's important is that if I were to multiply and distribute this a across both terms, like I've got it here, so 10 plus 10 cosine theta. So if I wanted to factor the 10 out and get the same result, I would have 10 times 1 plus 1 cosine theta. Okay, I'm going to go ahead and just leave it unfactored. So we'll set this up as, get rid of that. We're going to set this up fresh here as r equals 10 plus 10 cosine theta. Okay, so the thing about the cardioid is that the factor here has to be exactly the same as the constant here. And then if we look at the radius of the point from the pole to the rightmost point here, it's twice that a part. So it goes a radius of 20. And in this case, it's 20, 0, because in polar coordinates, from the pole, the radius is 20, but the angle is 0, and that point is where it would meet. Now, if I want to flip this guy around the y-axis here, all I have to do is change this from plus to minus. Okay, so it's following the direction, and because it's cosine, the action takes place on the x-axis. So it's going to flip about the y-axis, but this time if I wanted a polar coordinate, I could either say r is 20 and the angle's pi, that would put me here, or I could say r is equal to negative 20 and then the angle would be 0 again, but so that flips it over to this other side. Okay, now to see this shape we call a cardioid, if I want to see it in terms of the sine function, it's going to do the same thing, but it's going to flip over the x-axis and it'll top out at 20 or bottom out at negative 20. So let's start with, I'll just start fresh. So if I said, okay, I want radius equals 10 plus 10 sine theta, okay, because it's adding 10 plus 10 sine theta, it puts it in the positive, so twice the value of a, and a is 10, so the top's out at 20 here. So the radius is 20 and the angle is pi over 2. And if I want to change that, I'll just make that subtraction. And the radius is 20 and the angle would be like a 3 pi over 2, or you could say that the angle is the distance is 20 and the angle is negative pi over 2. So remember, there's multiple ways to identify a polar point. Okay, so that describes what we refer to as a cardioid. The other thing you want to look for in a cardioid is that it's always going to touch the pole, the origin. So that's where the two heart halves meet there at the pole. And it does not create any kind of a loop in there. So a cardioid is always going to look like that, and we've seen the 4 possibilities. The only other thing I might say is that if I want to change this to 5 instead of 10, that makes my radius for these polar coordinates 10 instead of 20, 2 times 5. And again, everything else is the same. I can change it to a cosine if I want it to go right and left, or I can use a sign for up, down. All right. So now that explains why in this particular case they've given us a graph of 1 minus sine theta, and the distance from the pole to the bottom, since it's minus, it moves down, and the distance from the pole to the bottom is twice 1, so 2, and then negative pi over 2 is the angle. So they've identified it, they've chosen to identify it as a positive radius of 2 and use the negative pi over 2 as the angle.